We're asked, how long does it take $500 to triple? All right, so how long time is it going to take $500 to turn into $1,500 if it is invested at 6%, that's our interest rate, compounded continuously? Let's use our compound interest formula, which says that A of t, that's the amount, depends on time, A of t is equal to P, that's our principal, the amount that we invest, E to the RT. R is the interest rate, T is the number of years. I'm just going to write down what we have. Here's what we have. We have that P is equal to 500, R is equal to 6%, so 0.06. And what we want to do is find T, and we also have this, right? We have that A equals 3 times 500, 1,500. So let's see, let's put it all in here. We're going to have A of t is 1,500 equals 500 e to the 0.06 t. And I think what I'm going to do here is I'm trying to get t, right? We want to get t. So let's start to isolate it. Let's divide by that 500. So I'm going to divide, I'm going to divide by that 500. So let's see, we will get, now this goes in so evenly, I'm just going to go ahead and do it. 1,500 divided by 500 is 3 equals e to the 0.06 t. Now, t is in the exponent, so this makes this an exponential equation. Let's solve the exponential equation by taking logs. The base is e, so I'm going to take natural logs of each side. So let's take natural log of 3. That will be, now I'll go ahead and write it this time, but you don't really have to do this. You could just simplify this directly from here, because you know that the whole point of taking the natural log of the exponential when they have the same base is just to get the exponent. So you could actually just write this step here. Natural log of 3 is equal to 0.06 t. Let's divide. T is the natural log of 3 divided by 0.06. And now I am getting that t is equal to 18, I'll round off, 18.31. So let's answer the question. The question says, how long will it take? The answer is not t equals, the answer is 18.31 years. Now while we're here, let's just do a very similar problem. The only thing I'm going to change here is this. We put in $500. How long would it take if we put in 600 or 6,000? If we still want to triple, and we're still going to get 6%. So what we would have in this case is, all right, starting with our formula, here's our formula, I'll write the formula. It's A equals PE to the RT, and what we want is A, right, so we want A to be 3 times whatever we invest. Now in the problem we invested 500, so we had, all right, 3p, so that's why I wrote it over here, 3 times 500. I'm just going to leave it now as 3p. So put that 3p in here for A and see what happens. So we'll get 3p equals p e to the 0.06 t. Now divide by p. So if you divide by p, and p is not equal to 0 because that would mean we're investing nothing, those cancel, right? And we get this. 3 equals e to the 0.06 t. Let's take, and actually before we take logs, you see this? 3 equals e to the 0.06 t. Look where we are right down here. So the amount that we invested, that went out, right? This problem is independent of how much we invest. We're going to get the same result. So since I'm here, I could work that straight down. I'm still going to get that t is equal to 18.31 or 18.31 years. So it doesn't matter how much you invest at 6%. If you compound it continuously, it'll take a little over 18 years to triple your money.